All right, lads. We're moving on to another pair of polygons, which is a pentagon. This is another key one that can come up in an exam, and it's really important just to understand the basics. Once again, this is just a bit of a resource if you didn't understand it. This is a bit of a difficult one. It can be a bit tricky for some students. It was tricky for me. I remember when I first learned it, due to you not being able to use a set square to do it, you have to do it completely through the protractor. And talking about protractor, I'll go through what you need. So you really need a ruler, which I'll just be using the t-square, and also just using the 60-30, but you don't necessarily need that. What you really need is your protractor. Protractor is really key with this, and then of course you need your 2H and your HB. So we'll start off now. Right, lads, before we construct this, we'll just go quickly over the principles when we're going through pentagons. So the key ones are, as I said when we're talking about the hexagons, the exact same principles in regards to length. So all you need to know is one side. That's all you need. So I'm giving this to here now, and the side here is going to be a length of 30 millimeter. And when you're fully constructed, all sides must be 30 mil. And once they are 30 mil, that means once you see and show that they are 30 mil, that means you're right. So so all sides are equal once again, and all angles are equal. The only difference between this and a pentagon is that the external angle is different. So with the hexagon, it was 60. Now this time it is 72, and the same principle or the same logic applies with because a pentagon, as you know, has 5 sides. When you divide a circle that has one side and has a total thing of 360 degrees, when you divide that by 5, you get 72 degrees, and that is your external angle for each side. Okay, so we'll start off by constructing it now. Like before, get your compass here, place it, make sure it is 30 millimeter, or just the length. Realistically, when we go through this in class, the length really doesn't matter, as long as your compass is always set with the length of your line at the bottom. That is the key factor. So yeah, you get your sharp end, you place it in one corner, at one point of the line, the end point. You point it in there, and then you draw a large arc like that. Just once again, like last time, just making sure you're covering as much ground as you can, making sure it's the same length. It is. Doing the other side now. Yep. All right, perfect. Now with your t-square and your protractor, bring your protractor, your dot here, right to the end line, the end point of that line. And just actually for it's easier to understand, I want to make this point A and point B. So let's go. All right, and then bring this back up here. Now, as we can see here, the external angle of this is 72. So how we do that is we go up here and we measure. We say, okay, this is 72 here. Bring it, mark a dot there. Perfect. And then on the other side, do the same. Now, it's a bit like when you're doing this, you kind of have to, some protractors won't have this 70 here. And sometimes you have to do a bit of math. So 72 minus 180 is this value here. And that is perfect. Okay. All right, and I'll draw on the lines now. I realized my page was a bit offset, so these dots here are a bit inaccurate. So just connect these two now green dots back to your point here, using your 2H, and using your 2H on this side as well. Perfect. Now you can just double check now to make sure that this line here and this line here, yeah, where that intersects, that is where your line is cut off, and that is where your two sides are formed. So yeah, they both look good. So I'm going to use my finished line, or my larger, my H or 2H or HB, whatever you're using. and finishing those lines, and that is our true construction now, or true lines, or true shape. Perfect. Now, that was very similar to the hexagon, but where the hexagon really, or the pentagon really differentiates from the construction of a hexagon is the final part here. So all we need to do really is to define the apex of, or apex means, of course, the total, the top point of the pentagon. And how we do that is we use our compass once again, set at 30, ensuring that this is always the same length as your compass. Put your compass in the dot where your true length ends, and then mark off a little arch there, or a little arc there, and then do on the other side as well. Copy to the other side, and that should be, that intersection there is the exact point where that pentagon, the apex of that pentagon exists. So just get my ruler, and that should be how you construct a regular pentagon. You see that? And once again, like we did with the hexagon, to prove to prove that this is correct, we look at our compass here. See, that's you can see, you can just check that your lines are all the same length, which they are in this case, and also your angle is the same. So the angle in here and the angle here is all the same. So yeah, I hope that was a bit helpful. And if any other questions, just shoot me an email, and good luck.